Actually, there will be two of us presenting. I want to present a project called Laser Class Protection, and I'm here with our company's CFO, Piotr Wieliński, who is with me. And we both represent this project. I start to manage it operationally as an executive. And the moment it starts, I can maybe have some images. Of course, they're not important because I can talk about the project without them. So I'm going to just skip into the presentation. It's working? Anyways, the project that we'd like to present is actually a cooperation between us and an American company that we came across last year, exactly a year ago in June. I took part in the U.S. Embassy program, Young Transatlantic Innovation Leaders Initiative. I was sent to U.S. for 3.5 weeks. 2 weeks of them I spent in Alabama, Huntsville. And everybody asks what you can find in Alabama, Huntsville. Actually, in Huntsville there is a perfect. We can skip to another slide. There is a huge hub of military companies, and there is 4-star generals sitting in this town, having a few billions of dollars to spend for those contractors for some new technologies for the army. So I managed to meet with some of the companies. In one of those companies, Aegis Technologies, that I came across with, we had a couple of meetings. The company is in bio cybersecurity, training solutions, technologies of modeling and simulation for the military. They developed high-tech technologies for the military that have only usage in military. One of those technologies is the protection, the coating for protection against laser penetration of glass or other materials. They are used for the pilots who are flying jets in order not to be shot by a laser, so they are protecting their eyes. And the company wants to commercialize this technology, but doesn't have a business development skills, abilities, as well as funding and initiative, motivation to do that. So we decided to work together. We, as BTM, are supporting the business development and acquire funding. And we said that we'll do the research and development for that project here in Poland. And after we get it done, and the product is the healthcare appliance of this technology. We want to do laser protection glasses for the lasers that are used in healthcare. You can say that the glasses for healthcare market is nearly 133 million this year and growing 5% annually. You can use the lasers are used for dental surgery, soft tissue surgery, dermatology, plastic surgery, ophthalmology. So there is huge need for this kind of protection. This technology can allow to have glasses that are against many frequencies of lasers, as well as have better protection abilities. They don't change the way people see things. They don't change any spectrum or visibilities. We decided we want to do this R&D here, produce these glasses here, and sell them on European markets, and with help with Aegis Technologies to sell them in American markets also. And I would like to ask our CTO also to maybe speak more about the technology and the problem behind it.
Thank you. So I will tell you a few words about lasers, how does it work. So in general, there are many intelligent people all over the world who invent lasers. They make gases or crystals shine. Those crystals shine the light with a very precise frequency, which means that's or a green light, or a blue light, or a yellow light. But this light can be also UV, which means ultraviolet, or infrared. In the medical area, there are many infrared lasers which are used, and mainly for any application, each application there's a different laser which is used. Which is a problem, because if somebody wants to make any kind of protection for the eyes, he has or she has to invent one pair of glasses for one frequency. And this is not very good for a doctor who, at the moment when he uses, for example, for eye operations in ophthalmology, something like 5 different lasers with 5 different frequencies, he has to have 5 different pairs of glasses. And this technology allows to overcome this problem. So speaking about the technology, what is being done, it's a superposition of very thin layers of metals and dielectrics. Those layers are of the order of nanometers, and it works in such a way that the visible light goes through because it has got a big length of a wave, and a short light is being trapped. So what is being done, people have to make a kind of a sandwich with something like 20 different layers of dielectrics and metals in order to block all the infrared light. So if all the infrared light is being blocked, so all the frequencies, only the visible light goes through, and 100% of the visible light is being seen by the doctor. So we will be making different kind of glasses, but they will differ only in the design. So the doctor will be able to have the kind of glasses he wants, but the material itself, this will be one kind of material and one unique technology, which is much cheaper than the solution which is today on the market. So we'll be selling it initially in EU. Our American partner will help us to get into the American market. The main problem is the certification. We have to go through different certifications in different geographies, which takes time, which takes money. We'll be marketing those glasses by different channels, so we think already now about how to fight with the big guys, like for example Philips. Philips has got a business with this kind of glasses, however they provide a set of glasses for each technology separately. Here, with a technology which is a kind of a breakthrough, we have to build a quite big marketing machine in order to bring this to the market and bring it to the final users who will be willing to pay for it. Well, the key value proposition here is to give to a doctor or to a person who is working with lasers one unique solution who will have only one pair of glasses instead of 5, and also a high visibility in the visible range, because the solutions which exist today, they block something like 80%, 70% of the visible light. So we hope it will be a success. There's still a few years of work in front of us, so we hope we will succeed. If you have any questions.